Welcome back. We are on section 1.3, ordering and comparing irrational numbers. Remember that an irrational number is just any number that cannot be written as a fraction. Our square roots that are not perfect squares, like the square root of 5, fit into this category. If you don't remember how to turn irrational numbers into approximations, go back and watch a previous video on section 1.1. Take a look at our first example. We're going to compare irrational numbers. That means we're going to tell whether certain numbers are less than or greater than other numbers. So there's a process as we go through how we convert irrational numbers into approximations. Okay, we're going to start with the numbers on the left side here and figure out about how much that is. So we have the square root of 3, which we don't know what the square root of 3 is, plus 5. Well, if we figure out what the square root of 3 is about, we can just add 5 to it, and that'll tell us what the left side is. So our first step, as always, is just to figure out what perfect squares the square root of 3 is between. The square root of 3 is between the square root of 1 and the square root of 4, which are both perfect squares. The square root of 1 is just 1. The square root of 4 is 2. So we know that the square root of 3 has to be somewhere between the numbers 1 and 2. So now that we know that it's between 1 and 2, we can just start picking decimals to the tens place that are between 1 and 2 and see when we square them how close we can get to 3. Okay, so I'm going to start off with 1.6 because I know that 3 is closer to 4. So that means that the square root of 3 has to be closer to 2 than it has to be to 1. So when I square 1.6, I do 1.6 times 1.6, I get 2.56, which is still too small. So I go up to my next number, and I square 1.7, and I get 2.89. Now remember, square means just to multiply by itself. You can do it with a calculator right now, or you can do it freehand, whatever you choose. Again, I'm still too small, but I'm getting really, really close to 3. So I pick the next number up. I do 1.8 squared. Okay, 1.8 times 1.8, and I get 3.24. So I have 2.89, and I have 3.24. This one is only 0.11 away. This one is 0.24 away. So 1.7 is our closest approximation. That means that the square root of 3 is about 1.7. And we can use this and now add 5 to it. So we have 1.7, that's what the square root of 3 is, plus 5 gives us about 6.7. Okay? So we know what the left side is. Now we take a look at our right side. The square root of 5 is between, and I'm going to move a little faster this time, the square root of 4 and the square root of 9. The perfect squares that it's between. That means the square root of 5 is between 2 and 3. 5 is much closer to 4, so I'm going to pick decimals that are closer to 2 than are to 3. So we'll start with 2.2. We'll square it. 2.2 times 2.2 is 4.84. Still too small, so I go to the next number, 2.3, and I square it. So that means I'm doing 2.3 times 2.3, which is 5.29. So I have one smaller, one bigger. I can figure out which one is closer. 0.84 is 0.16 away. 0.29 is 0.29 away. Therefore, 2.2 is a little bit closer. So that means I have 2.2 plus 3, because I still have to add 3 to it, and I get 5.2. Now I'm just comparing a decimal, 6.7 and 5.2. And we know that 6.7 is larger, so we say the square root of 3 plus 5 is greater than 3 plus the square root of 5. Take a second, pause the video, try your turn, and then come back and check your answers with what I have. Okay, so for number 3, we have 2. Square root of 2 plus 4 plus 2 times the square root of 4. Square root of 2 is an easy one to figure out. Okay, it's between the square root of 1 and the square root of 4, which means it's between 1 and 2. Sorry about my handwriting. Okay, 2 is slightly closer to 1, so I'm going to pick numbers that are slightly closer to 1 than to 2. So we'll start with 1.3 and we'll square it. So we'll do 1.3 times 1.3, or you can think of it as 13 times 13. And then you bring your decimal points over, it's 1.69. Okay, we're still well below, so we go to 1.4 and we square it. 1.4 times 1.4 gives us 1.96. I doubt we're going to get any closer than 0.04 away, but we have to try 1.5 just in case. 1.5 times 1.5 gives us 2.25. So clearly this is closer, so it's about 1.4. And we have to add that 1.4 to 4, which tells us that this whole thing is about 5.4. The other side's much easier because we have 2 plus the square root of 4. The square root of 4 is a perfect square. It just equals 2. So this side is just 2 plus 2, which is 4. And now we're comparing 5.4 and 4. So we say that the square root of 2 plus 4 is greater than 4. Okay? Let's take a look at number 4. Number 4 is a little more complex. Okay, we have the square root of 12, which is between, what, two perfect squares? The square root of 9 and the square root of 16. Okay, which means it's between 3 and 4. 12 is almost in the middle, but it's a tiny bit closer to 9 than it is to 16. So we'll start with 3.4 because it's really close to the middle, but not quite there. And we'll do 3.4 times 3.4, or 3.4 squared, which is 11.56. Okay, we're still below, so we go to 3.5 when we square it. We do 3.5 times 3.5, and you get 12.25. Okay, this one is 0.44 away. This one is 0.25 away. So this is slightly closer. So we're going to substitute 3.5 in for the square root of 12. So we have 3.5 plus 6, which is just 9.5. Okay, now we have to figure out the other half. The square root of 6 is between the square root of 4 and the square root of 9. So it's between 2 and 3. Okay, 6 is much closer, well, not much closer, but a little bit closer to 4 than it is to 9. So we'll pick 2.4 and we'll square it. 2.4 times 2.4, and we get 5.76. I go to my next number, I do 2.5 and I square it. 2.5 times 2.5, and you get 6.25. This one's 0.24 away, this one's 0.25 away. This is our best estimate. We could use either one, and we'd be pretty darn close. So we substitute 2.4 in for 6, and we do 12 plus 2.4, which is 14.4. So we would say that the square root of 12 plus 6 is less than 14.4. Okay, I recommend stopping at this point, taking a break, and then coming back and watching the rest of the video. Okay, we're going to work on ordering them in the next section. So now we're going to work on ordering irrational numbers. Okay, that means we're going to put them in order either from least to greatest or greatest to least, depending on what they're asking of us. Okay, so it says order the square root of 22, pi plus 1, and 4.5 from least to greatest. And it's super important that we see what we are doing as far as from greatest to least or from least to greatest, because that tells us what order the numbers need to go in. So the first thing we need to do is determine the value of each number. Let's do the ones we already know. We should know that pi is 3.14. So pi plus 1 is about 4.14. About, not exactly. Okay, 4.5. 1/2 is 0.5. So we know that 4.5 is 4.5. And the square root of 22, we have to do a little bit of math. We know that it's between the square root of 16 and the square root of 25. because we're doing the same thing we just did in the previous section and the same thing we did in our 1.1 notes. Okay, which means it's between the whole numbers 4 and 5. 22 is slightly closer, so we're going to pick our numbers that are closer to 5, like 4.7, and we're going to square 4.7. And we get 22.09. Okay, so we go down to 4.6 just to make sure there isn't one that's closer, and we square 4.6 and you get 21.16 when you square it. So that means that 4.7 is slightly closer, so we can say the square root of 22 is about 4.7. Okay, and now that I have these values, it's pretty easy to put them in order from least to greatest. Pi plus 1 is the smallest, so we say that pi plus 1 goes first. Next would be 4.5. And next would be the square root of 22. And just make sure when you put them in order, you use their original values. Not 4.14, you write pi plus 1, you write 4.5, and you write the square root of 22. That is how we order them from least to greatest. If you're still confused, we have a few more examples we can look at. So we're given our number line here, and we're looking to order our three numbers from least to greatest. Okay, we have the square root of 5, 2.5, and the square root of 3. We know right away, first off, that the square root of 5 has to be larger than the square root of 3, because obviously the square root of, or 5 is larger than 3, so our square roots are still going to be larger. But we need to figure out about what the square root of 5 is. Okay, it's between the square root of 4 and the square root of 9, so it's between 2 and 3. Okay, 5 is much closer to 4, so we're going to start with numbers that are really close to 2. So we'll square 2.1. 2.1 times 2.1 is 4.41. So we got to go larger. We got to do 2.2 squared, which is 4.84. We're still not there. We still have to keep going until we get above 5. And when we square 2.3, we get 5.29. 0.84 is 1.6 away. That's 0.29 away. So 2.2 is our best approximation for the square root of 5. Now we already know our order, because if the square root of 5 is 2.2, which goes about right there, let me write that a little neater, and 2.5 goes there, we know the square root of 3 is smaller than the square root of 5, so we should be able to figure out our order already, but we need to plot the square root of 3 on our number line, so we quickly try and figure out about what the square root of 3 is. It's between perfect squares 1 and 4, which means it's between 1 and 2. 3 is slightly closer to 4. We did this before. We square numbers that are closer to 2 than to 1, so we'll start with 1.7, and we'll square 1.7. And when you do that, you get 2.89. It's slightly below 3. So then we have to square 1.8. You get 3.24. 2.89 is slightly closer to 3 than 0.24, so we say it's about 1.7. So it'll go here on our number line. From least to greatest, that means the square root of 3, the square root of 5, 2.5. Our last example is pi squared 10 and the square root of 75. We can start with pi squared. We know that pi squared means 3.14 times 3.14. And when I square that, I get 9.8596. Here. Okay. That gives me the value of that, 10. I don't have to do anything, that's 10. And the square root of 75, I have to figure out about what that is. This one's a little more difficult to figure out the perfect squares that it's between, but 81 is really close. So I can always go, I know that 81 is 9. I can always go down to the next one at 8. Square root of 64 is 8. So I know the square root of 75 is between 8 and 9. It's closer to 9 because 75 is closer to 81 than it is to 64. So I start picking numbers. Let's start with 8.8. 8.8 times 8.8, we square it. I get 77.44, so I have to go down 8.7. And I want to square it, so I want to do 8.7 times 8.7. Really helps to have a calculator on hand. 75.69. So it's about, we can say it's about 8.7. Plot them on the number line. 10 goes at 10. Pi squared goes at 9.8, so it's just below it. And square root of 75 goes at 8.7, so it's all the way down here. Okay, that means if we're going to put them order from least to greatest, square root of 75 is the smallest, then 10, then pi squared, hope you caught that, then 10. Okay, again, you figure out about what each of these numbers equal, then you can plot them on your number line and read them from left to right for least to greatest, or from right to left for greatest to least. Hope you understood this. If you have any questions, please ask, leave a comment, or do whatever you need to do.